Hi, welcome to AP Calculus at East Aurora High School. Today we're going to continue in Chapter 2, Section 1 with finding the derivative by the limit process. So the limit that we used to define the slope of a tangent line on our last video is also used to define one of the two fundamental operations in calculus. That operation is called differentiation. It is the process of taking the derivative of a function. So we're going to have a formula that looks very similar to finding the slope of a tangent line. The formula that we will be using is f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Notice that we're generalizing the formula that we use to find the slope at a certain point on the curve. Instead of having the c, we now replace that c, that constant, with the generic variable x. Also notice that I'm using delta x as the distance between my 2 points on the x-axis. You also can use the variable h. So if you prefer to say the limit as h approaches 0, and every place where I have a delta x, you have an h, that's absolutely fine as well. We will see both notations in our textbook. Let's go ahead and find the derivative of the function f of x equals 4x squared plus 3x using the limit definition of the derivative. Using the formula in the box above, we're going to say f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So remember that every time we want to find f of x plus delta x, we are just going to take x plus delta x and replace the x in our equation with x plus delta x. So both of those x's will get replaced. It should now look like this. The limit as delta x approaches 0 of 4 times x plus delta x squared plus 3 times x plus delta x. That takes care of f of x plus delta x. Now we're going to subtract the whole function, and the function, of course, is 4x squared plus 3x. And put the whole thing over delta x. Now it's just a matter of simplifying the algebra before we take this limit. So once again, this is the limit as delta x approaches 0. I've got 4, and I'm going to multiply that by the quantity x plus delta x squared. So let's square that quantity, getting x squared plus 2x delta x plus delta x squared. We'll have to distribute the 4 in just a minute. Plus, let's distribute the 3, so we now have 3x plus 3 delta x. And I'm going to distribute the subtraction, so it's minus 4x squared minus 3x all over delta x. Now I'm going to go ahead and distribute the 4, so I've got the limit as delta x approaches 0 of 4x squared plus 8x delta x plus 4 delta x squared plus 3x plus 3 delta x minus 4x squared minus 3x all over delta x. So now it's just a matter of simplifying by canceling off like terms. So I see a 4x squared here is going to cancel with a 4x squared here that's negative. I also have a 3x that's going to cancel with the negative 3x. Now we should notice that all of the terms that are left still have a delta x, so I can go ahead and divide each term in the numerator by delta x, and then take the limit as delta x approaches 0. So in the case of the first term here, I've got 8x delta x, and I'm dividing by delta x. So that, of course, is going to give me 8x. Now I've got 4 delta x squared divided by delta x, so that leaves me with a 4 delta x. And lastly, I've got 3 delta x divided by delta x, so that's going to be a plus 3. If I substitute 0 for the delta x, then that tells me that my answer for f prime for the derivative is 8x plus 3. So I would write this as f prime of x, and again f prime stands for the derivative, is equal to 8x plus 3. You'll notice that this time we got a function. In our last lesson, when we got our answer at a certain point, then our answer for the slope of the tangent line was a number. It stood for the slope. This derivative is a function, so that at any point x, I could find what the slope of the tangent line is using this function called the derivative. Let's try another example. Example number 2 says find the derivative of the function f of x is equal to the square root of x minus 2. So we're going to use our limit definition to find f prime of x. So our formula says f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So I'm going to substitute every place I see an x in my original function, I'm going to replace it with an x plus delta x. So it's going to look something like this. The limit as delta x approaches 0 of the square root of x plus delta x minus 2 minus the function, which is the square root of x minus 2, all over delta x. So when we try to do this limit, we see that we have the type of limit where we're going to have to rationalize the numerator. So let's multiply this whole function by the conjugate of the numerator. So I'm going to say the square root of x plus delta x minus 2 plus the square root of x minus 2 all over the very same thing. So the square root of x plus delta x minus 2 plus the square root of x minus 2. Now in the numerator, when we're multiplying conjugates, we multiply the first 2 square roots. So we're going to say, let's take this square root and multiply it by this square root. And that, of course, is just giving me that term without the square root. So x plus delta x minus 2. Outers and inners would cancel, so then I go ahead and multiply the last, but I have to subtract that product, so I'm going to say minus x minus 2 all over, and I'm not going to distribute the delta x. I'm going to say delta x is being multiplied by x plus delta x minus 2 plus the square root of x minus 2. Now this limit I'm just going to arrow down so that it's going to be at the bottom when I'm ready to take the limit. You'll notice that when I put together my like terms, this x and this minus x cancel. Negative 2 minus a negative 2 cancel. So that tells me that in my numerator I have just a delta x. In the denominator I have again the product delta x times the square root of x plus delta x minus 2 plus the square root of x minus 2. The delta x's cancel in the numerator and denominator and leave me with a 1. So now I'm ready to take the limit as delta x approaches 0. And when I do that limit, I end up with 1 over, you'll notice that this part right here, that delta x goes to 0, so I've got a square root of x minus 2 plus another square root of x minus 2. So altogether there are 2 square roots of x minus 2. So I would write this as the derivative of this function is the function 1 over 2 times the square root of x minus 2. For our last example, let's take a look at the derivative of the function 3 over 2x plus 1, again using this general form of the limit definition of the derivative. So I'm going to go ahead and say once again that our formula is f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Now don't forget to add this formula to your formula sheet that we made, the gold formula sheet. This is a new formula for chapter 2. So we want to replace the x in the function with x plus delta x. So I'm going to replace it right in there. And I'm going to say that this is the limit as delta x approaches 0 of 3 over, I'm going to go ahead and distribute the 2 right away, so it'll be a 2x plus 2 delta x plus 1. Now I'm going to subtract f of x, so that's going to be 3 over 2x plus 1 all over delta x. Now here's a case where we ended up with a limit that if we substitute 0 for delta x, that's going to give us the indeterminate form. So we of course know that we need to rewrite this one. I have a complex fraction, so I'm going to multiply every single term by the least common denominator, which is pretty complicated. 2x plus 1 times 2x plus 2 delta x plus 1. And that's going to happen both in the numerator and the denominator. I'm hoping for cancellation in the numerator. And in the denominator, I do end up with this factor. So for my first fraction, still I'm going to keep my limit as delta x approaches 0. In the first fraction, the whole denominator cancels with the factor 2x plus 2 delta x plus 1. So I now have 3 that's going to be multiplied by 2x plus 1. In the case of the second fraction, the 2x plus 1's cancel. So now I'm going to have 3 multiplied by 2x plus 2 delta x plus 1 all over delta x multiplied by the product of both of our least common denominators, 2x plus 1 times 2x plus 2 delta x plus 1. So when I go ahead and distribute that numerator, I'm going to now have 6x plus 3 minus 6x minus 6 delta x minus 3 all over delta x times 2x plus 1 times 2x plus 2 delta x plus 1. So I can see that I've got like terms in the numerator, so the 6x will cancel with the 6x, 3 will cancel with the negative 3, leaving me with just a negative 6 delta x in the numerator. Well, that factor of delta x right here in the numerator can then cancel with delta x in the denominator. Don't forget to keep the negative 6 though, because that's a multiplication there. So this limit is going to turn out to be negative 6 in the numerator. In the denominator, this delta x goes to 0, so I actually have 2x plus 1 multiplied by 2x plus 1. Well, when I multiply 2x plus 1 by itself, it's giving me 2x plus 1 squared. So the answer that we were looking for is that the derivative f prime of x is equal to negative 6 over 2x plus 1 squared. So again, this represents a function. It's a function that we can use to find the slope of the tangent line at any given x value. So it's a more general way of writing the slope of the tangent line. We're going to practice some of these in class tomorrow. So please take notes on this and add this formula to your formula sheet so that you're prepared to do practice in class. Have a great night. Bye-bye.